Hello YouTube, RJ. Hey, we're back on the bench with the 428B clip-on DC milliamp meter. And if you remember where we left it, I had just replaced some parts and just got the voltages looking right. And so we now have 12 volts instead of 50 volts. And prior to that, like 150 volts. So we got everything done. I replaced the capacitor, the 50 volt capacitor that exploded, replaced the capacitor that was leaking and the other one that I was worried about. And we had just figured out that the schematic had an error in it. So I've got those swapped, and voila, we got our 12 volts. Things look better. Voltages all work. So now we've got our 272 high voltage pinned right on 272. We've got our 12 volt, and I checked as per the instructions, I checked this -7. We had -6.6. They want -7 plus or minus a volt. So anything between 6 and 8 is good. We were 6.6, good with that. So now we're moving on. So let me get the mouse out of the way for the moment. So what we got going on over here is we're doing the DC amplifier balance. I want you to open it up and short across with the brass pins on the circuit board, connect to the ends of C10. These pins are located on either side of C14, and that's what, if you can make out in here, the green jumper is doing right here. Then it wants you to connect a 1500 ohm, a 1.5K resistor between pin 2 of V6 and the 6.3V filament supply. Disconnect the feedback disconnect. Okay, so first of all, the 1500 ohm resistor is over here, jumpered to the pin 2 of V6, and then I found the 6.3 on V6, and I've jumpered to it. Disconnect the feedback disconnect. Don't know if you can see it over here or not, but there's a little red wire here I've got pulled out from everything. It plugs in the circuit board right down here. Disconnected it. So we're good. It says disconnect feedback, figure 7.3. Now zero the 428V meter with R46. If you look at the layout, if it's not lying to me, this yellow pot. So right here, you see this yellow pot right here. And that's going to be what we're going to be adjusting. And you should be able to see the meter over here, although there's a lot of parallax. I'll move it a little bit for you. It's a lot of parallax. You're going to have a hard time seeing. But right now, we are not zeroed. So let me get this thing zeroed. See if it will zero. Will it move? Oh, yeah. Wrong way, but it will move. I've got it propped up a little using the mirrored screen to try to make sure I get it dead on. Okay, that is dead on zero. Okay, zero the meter with R46. Okay, remove the clip lead and resistor and replace the feedback disconnect jumper. Okay, so we'll go ahead and turn it off. Remove this. Okay, and the 1500 ohm resistors out of the way. And I got to replace the feedback jumper, which I'll take this down from this to do that. Got to get in down here, wires. See if I can get that hook back up. I'm gonna roll him up to do it. Okay, give me just a second. I'm gonna move the camera for us again. All right, so I got to get this red wire hooked back up. And that gray cable is right in my way down here. It's not easy to do this. I might try to go in from the side. Okay, he's back on. So he's back on. So everything except for this needs to come off. And the DC amplifier balance is done. So we've got that one done. So now it's time for the alignment. Wants me to construct a probe as shown below. Wants me 2 10K resistors hooked up. Connect the ends of the probe to T5 side of R4 and R95. Connect an AC voltmeter between ground and the junction of the 2 probe resistors. Adjust the oscillator balance. Pad 53 or 54 for minimum reading. On instrument serial prefixes of 601 or below, adjust the slug on T5. AC readings of the junction probe. Okay, got to set all this up. It's going to take a few minutes. Got to get my AC. I'm going to use my 3400A. Let me pull it out get everything set up that I need, get the resistors and stuff, and we'll be back. Okay, I'm back. So here's what I've done. Next step was to make up this probe out of two 10K ohm resistors. So I went through my 10Ks and I found two that were very, very close, soldered the middle together. The only way I could connect them was to solder them. It wants you to connect them to the T5 side of R9495. I had to solder them on the board over here. That's what I did. You can see I've got out my 3400A. I got it connected up, powered it up, and what you're looking for is to try to get as low as you can get. They want it to be below 50 millivolts. Well, I'm on the 30 millivolt scale here, and we're about 18.5 millivolts. So I would say we're in real good shape there. I think that's good. I don't think we need to worry about that. So I've done that. Now I got to test the oscillator frequency. I've got to get set up with a frequency counter to check the frequency. So I'll get all that rigged up and come right back. All right, I've got everything hooked up. Frequency counter hooked up to test point 4 and grounded. And it's reading 40.170 kilohertz. And we're allowed to have up to 200 off. It was less than that. It's bouncing around a little bit, but that's looking good. So I'm going to take a look at the oscillator lever. We'll test it. So I'll be back when I'm ready to do that. Okay, I'm back. Here's what I've done. As per the instructions here, I went ahead and connected an AC voltmeter here to test point 6, which turns out to be pin 7 of V7, so I'm clamped on there. And you're supposed to adjust R92 for 8 volts plus or minus 4 volts. Well, I've got 8.467. I'm a little high. I got a little bit of a problem. I tilted a little so we can get it in this camera over here. Potentiometer they're calling for is this one right here. And if you look carefully, there's nothing left of the stub for the potentiometer. It's gone. It's shot. It's just destroyed. It's come apart. Tried to get in there and play with it with the tweezers. There's nothing to get a hold of. So I'm right on the verge of being where they is acceptable. But I sure would like to get it better than that. But I don't know that I'm going to come up with a pot to replace that with either. I've got pots, but I don't think any of them are going to fit that. The only, unless I start stealing from the other one, I could see if there was one in there, but then we're back to now, we're making that one, taking that one out of being usable. So not ready to do that yet. Like I said, I don't even know if they've got a pot in there that matches. I'd have to go do research on that. We're just out of specs a little bit. Is it enough to be a problem? I don't know. I would like to get it closer, so I'm going to think about it. So let me think about this a minute before we go on, and I'll come back and decide if I'm going to do anything or move on. So, all right, we're back. Thought about it. When I looked at the other one, it doesn't even use the same pot. It uses a standard pot mounted on a 90-degree bracket. So I went in and got a 50K pot. I put some electrical tape on it to make sure nothing ever shorts out down here. And I added some legs to it, and I'm going to replace it. So we can adjust that. It's going to take me a minute. Got to desolder the old one, get it out. So let's jump on it and get it done. Power's all off. All right. Make sure we get the right thing here. It's right there. Okay, so I'm taking this out right here. See if we can get it out first. Probably need to add a little new solder to those. It's probably going to work a lot better if I do. Now, not going to be the easiest thing to get out, to be honest with you. Now, I guess I'm probably going to end up better off with the hot gun heating and taking that out. You're not going to see this. I'll go ahead and take care of it. It's going to take a few minutes for the gun to warm up and everything. We'll get this taken care of and I'll be back. Okay, I'm back. Here's the corroded piece of junk we took out of that thing. And here's our little pot installed. Definitely not OEM, but should be acceptable. And we're rigged up. Let's see what voltage we get now. Don't know where it'll be because the pot's just randomly. Give her a minute to warm up. It's looking like around 6.54 volts. All right, let's see if we can adjust this now. Yep, that's the wrong way. Oh yeah. So we want 8 volts plus or minus 0.4. I'm going to say that's as close as I can get right there. Still moving around a little, climbing. I mean, it doesn't need to be perfect, but, you know, we'll bring it down just a little bit since it's climbing as it's warming up. It's looking pretty good right there. 7.998, slightly climbing. It's going to be 8 in a minute. There's 8. 1 millivolt over. I would say we will safely stay within 8.4 volts. I'm going to call that one done. So let me take a look here. What do we got to do now? Another piece of junk came out of this. Okay, detector gate. Connect an AC voltmeter test point 4, pin 7 of V5. No, pin 7 of V5. I got to move to V5. Adjust L7 for a peak reading. Lord, hope that's something I can adjust. All right, so pin 7 of V5. So let's kill the power. It's going to be right here. So I'm going to pin 7. This will be pin 7 of V5 right there. And adjust L7 for peak values. Let's let this thing start warming up. Doesn't tell me what to expect, just says peak the reading on L7. So L7 is right here. So I'm going to get in here on this pot, or inductor, I guess it is. It's going down, it's going up, it's going down. It's pretty close to the peak I can get out of it right there. We're done with that. Next section is tune amp. Okay, we're back. I went ahead and set up for this following the equipment setup. I've got my signal generator putting 100 hertz signal out at 2.522 volts peak to peak, which is getting me 35 milliamps of current through it. I've got the clamp on to it. I went ahead and this is in 100 milliamp range. So for the input alignment, I shorted TP1 and 2 on the board to ground. That's these two jumpers. And then I disconnected the feedback disconnect again, the red wire we pulled previous for some other tests. And then what I did was the C2, which is just a small variable cap right here on the board. I adjusted it and peaked out to get the very most AC current voltage I could. We're done with that step. We're ready to the next step. Next step is called interstage alignment. Set up equipment as a paragraph 545. Okay. They want you to put oscilloscope in. I'm looking at what they got going on here. Let me read up on this, figure out what I need to do for the next stage. I'll get set up and bring you back when I'm ready to do it. All right, I'm back. And guess what? Ran into another major problem. The next step had you adjust L7. And L7 is a circuit board variable inductor right here. This is the old one. This is the new one. I'll show you that in a minute. This is that variable inductor. And this little thing you can barely see here is the magnetic core that you're turning to vary your inductance. And this is the back of it. And this is the coil that sits in it. And what happens is there's a little captured plastic washer in the bottom of this little ringed area that magnetic core connects to. And so you had a little screwdriver slot in there, when you plastic screwdriver slot on one end of it, and it was attached to that washer that holds it from coming out. And so it allows you to turn, the washer can turn in there, but it can't come out. Allows you to adjust the inductance. The moment I put my screwdriver in or adjust, I mean, literally just put it in a touch, all of that crumbled. The core fell out. The meters went off the scale and went crazy. And I was in trouble. I pulled it off, took it apart to see if there was anything I could do. There's nothing I could do. This plastic it'll crumble if I just rub it. In fact, most of it's all gone now. So I thought, well, there we are. Now we got a mess. By the way, this tray is the parts that came out and been replaced in this unit thus far. That's that. So I go online, I say, man, can I find one of these? No. As expected, no way. So here's the current one. This is the current one. You can see L7 is here. It's a 16 microhenry, 16 ohm. So here's the old one that I've got back here that we basically can't repair. It's not really a donor to be fixed. It become a part donor at this point, as far as I'm concerned. So I go and I look at its schematic, and guess what? L7 is a 16 microhenry, 16 ohm variable inductor. Same thing, except for one little thing. This is a later model with a circuit board, and that's one with a chassis. So you know what a variable inductor on a chassis looks like. It looks like this right here, suspiciously like that. In fact, that is L7 from the old meter. So not being able to get that part, I went ahead and scavenged the part from the other one. I just mounted this to the frame, the can, took the wires and put them in the circuit board, and went back to doing my adjustment. Adjustment went fine. Went through the last few steps, which were nothing, out of the ordinary. Hook a meter here, clip this here, adjust till you get this voltage. That went fine. In the end, I'm happy to say we've got a working meter that appears to be quite accurate, actually more accurate than they claim. They say 3%. Seems to be better than that, and I expect that from HP. HP was always known in its day for under promising and over delivering. I mean, the specs were always worst case scenario, and your meter usually worked a lot better than they said it would. And I'm going to say this is the same way. So now what I want to do is I'm going to put this all away, set this rascal back up, set up a test over here, and we'll try this thing out and see how well it works. So I'll be right back. All right, I'm back. I've got set up here where I've got my linear power supply feeding current over to my 34401 meter and returning back the power supply so I can adjust the current over here on the lab supply and see exact current reading on the Agilent. The HP is clamped around it in the correct direction. I'm on the 100 milliamp scale. I've zeroed the meter, which every time you change range, you have to do that. So I've got this adjusted the best I could to 30 milliamps. Very hard, tricky to get this analog meter or analog power supply to exactly anything, but get it real close. See where we're at. Okay, 30.25, and I don't know how much parallax the camera is going to have. We're pretty much dead on 30 milliamps. We're on the 100 scale, so we're the top scale. 20, 30, we're pretty much dead there. So let's go to a 30 milliamp, should be full scale. I need to turn the power off and zero the needle like that. And now let's see what we get. We're just a little over 30 milliamps here, and we are barely, like, not dead on the line, slightly above on the 3 here. We're pretty much on the 3, yep. So yeah, this is 30.027 now, so this has dropped closer to 30. So we're looking good there. Let's go back to 100. We'll have to recenter the 0 again and get it on. Okay, now let's see if we can get 100 milliamps going through. Let's see, 89, 90, 104, 101. Really touchy to adjust this current on this thing. Get her as close as I can get her. There you go. It's close to 100 milliamps as I can get. And she is, align the mirror up for parallax. She's 100. I mean, you know, they say 3%, that would be 97 to 103. And you can clearly tell, even probably with your parallax, that we're nowhere near that. We're way less inaccuracies than that. That's looking good. Let's go to 300. Kill the power. Go to 300. Zero it and see if I get a 100 milliamp reading on the 300 milliamp now. Okay. We're reading 100.11, and we're maybe a little low on this one. We're probably 99, line the line up, 99.5. So a little off. That's pretty darn good for a inductive measuring DC meter of this vintage. Yeah, this thing was built long before I was born. I'm pretty impressed with them. Very happy. We're done with the getting it working. You know, we went through the doesn't even power up, getting it working right, getting it accurate. At this point, I would put the case on, we'd be done. Now that I've got this thing working as well as it's working, I really want to go ahead and take the cosmetic part of it, the outside, to being as nice as the meter internally works. So I've decided to go ahead. This is going to be a keeper for me. I'm going to hang on to this instrument. So what I'm going to do is I'm going to go ahead, completely restore it. The next video, we'll go through and actually, I'll show you how I'm going to do this, where I'm going to keep all the print on the case and all of that, and make a really nice looking instrument. You know, the handle's kind of rough. I'm going to see if I can do something about that. Tune in next time to see how this thing finally turned out. Thanks for hanging out with me. Hope you learned something. Hope you found it interesting. But most of all, I hope to see you in the next video.